Do you want to know what's the difference between these two graphics? Why this one is actually not good and why this one is good? Maybe you've seen our social media post on this and you were wondering what is actually the difference. Or you have been following our comments on this post and you want to get some answers on that comments. So I will go into details as well, talking about retrofit, because it's easy. If we can build new, we can make the decision on, but how do we deal with retrofit? How do we deal with masonry, timber frame, and all these bits and pieces? So in this post, I will go into details. And as well, I will show you what we show in the designer course now as the final solution for this detail, and not just that step in between that we're showing you here right now in this graphic. So what's the difference? Let's start. So you see here, this one has this big red circle through, and we shouldn't go this way, and we should go this way. So what is the difference? So if you're looking to this part here, this one is far narrower than this part here. Yeah, and this is the main difference. Yeah, so the problem is that here in the corner where we already have a thermal bridge, and a thermal bridge is a cold spot, and a cold spot is a mold spot, and that's the reason why we're normally having in this area mold problems, because the thermal insulation has not the full thickness of insulation. And that's what we're seeing here. On this side, this thickness has been continued to the outside. There's only this little corner missing here, what has not such a big impact because it's that last little bit. And now with this, we're getting the thermal insulation thickness over that corner and able to eliminate or minimize this thermal bridge. How did we do that? We do that by actually putting in here this little timber piece. So we raise the whole roof structure. So if you have limitations in height, you may have to change the angle. Things like this have to be considered, obviously, if you have height restrictions. But this is the difference, that we have this step truss. And with this step truss, depending as well on your area where you are, there's many different wordings for this type of truss. But show to your manufacturer this graphic, and they totally know what you're talking about. And by this, you can get the required thickness into your roof. So that's the difference. Here we get enough insulation in because we're stepping our truss, and here we keep running our truss to the outside. And by this, we don't have this step. And by this, we're not getting the required insulation into the corner. Typical mistake, not easy to spot. When I looked at the two graphics, it took me a little bit of time as well to see the difference again. And this is the reason why it's so important. This little change, this little detail makes such a massive difference. So the one that we're having here, this probably causes mold problem and health issues. And this one here actually has no mold problems and health issues. And by that, we are in a far better position. To show you what we actually show in the designer course, so I first want to show you the ideal solution, what is perfect, and I'll show you all the little bits and pieces in there. And then I want to go into the retrofit, because the retrofit is a different kettle of fish, because we have to fix something that we have no control over what was done before. So by new builds, we can do it right from the beginning. And if you have proper training, then it's relatively easy to actually do it right from the beginning. Far harder is to actually fix something that is existing, because we have now a situation that is not ideal. And now we have to find a solution that brings us again to our Passivhaus levels. So for this, I want to share my screen. So now you should see a detail. I'm using Paint because it's an easy tool. Here you see now this perfect detail for this solution. So I want to show you a little bit of the things what you see here. First of all, you see in green, this is our airtightness system. Yeah, that's our airtightness system. Then you see in red, you see our thermal envelope, and you see in blue our weather tightness. So I often call that the second layer of defense, or I call it weather tightness. Yeah, so that's where we are having our windbreak and stuff like this. And then another thing I want to point out to you straight away before we go into the details is, like, you see this orange part, these are the joints in our weather tightness or air tightness systems. So that's the first thing that I want to show you. Here you see again that stepped roof. So we put in this timber here, and by this we're stepping it. But in here, there's so much more details. So let me walk you through from the inside to the outside. Here, our ductwork. So this is our ductwork. We're having like this dropped ceiling so that we can run our ventilation system ducting in there. So that's our heat recovery ventilation system. And we're showing that in here with massive ducts. In this case, it doesn't need to be that big. Normally, they're like just 100 millimeters big, the ones that we normally use. So with this, we normally have not that massive drop, but make sure that you have enough drop. Sometimes I've seen people dropping it not enough, and then they're running into trouble. You definitely want to have that on the inside of your air tightness system. Yeah, you see our green line is on top of that. And this is really, really important, because otherwise you're running your system from the inside to the outside. And then because of in that ducts, you have now the indoor condition running there. And then if you're running it on the other side of the air tightness system, now this indoor temperature in that tubes has now access to the outdoor condition. And by this, you could get enough pressure drop between the conditions that we're getting a thermal loop, and then we're getting energy losses. I've seen it in different projects that I've been involved in, where the client was too stubborn and didn't want to do it. And it caused a lot of energy losses and not having that 80, 90, 95% heat recovery any longer because of that decision. So we dropped the ceiling to put that in. Then as well, a really important detail that we see here, if you're following this membrane that was put on here, we're having here this little loop. So we're leaving a loop in that corner because of expansion. It could easily be that your roof structure is expanding differently to your wall structure, and that you have movement. And this is something we have to allow in the air tightness system. That's the reason we normally put like this little loop in there in that corner, so that we can keep the tension of our taping. And then you see as well, we normally run our membrane from the roof then down onto the wall structure, and then we can actually tape wall membrane to the roof membrane on the horizontal. What is easier, sometimes you see people doing it on the ceiling. The problem with the ceiling, I want to show you, if you want to tape it on the ceiling, there's one thing that you need to do. You need to put in here noggins. Yeah, you need to put in noggins into this area so that you can actually staple your membrane on it, and that you have a continuous lane of staples in the membrane. Otherwise, there's too much pressure on it. And when you do your blow-door test, you easily rip it apart. It happened to me as well when I was blow-door testing. The client should have been really happy of me doing that, because it's shown that the air tightness system hasn't been installed properly. And that pressure difference is 50 Pascal. We normally go up to 100 with our testing, depending where you are. In Australia, you'd rather go 90, 80, 90. In other areas, like in Germany, like you often go above 100, build up the pressure. And if this is now too much pressure for the pressure difference between inside and outside, and it's ripping that apart, that means that the air tightness hasn't been installed properly. That will be then shown in the air tightness test. And to avoid that is you're putting noggins in here and then staple it on it and fix it there. If you have fixed it on the ceiling, better is always bring it out of the ceiling and make the connection point on the wall, and then having that pressure on the joint rather on our timbers here that are then able to release that pressure. So now we spoke about the inside and how to achieve our dropped ceiling and why we do it. We spoke about our air tightness system, why we do it, and then our thermal insulation needs to be continuous and complete. Now let us move to the outside, and we're showing here a ventilated roof space. The problem with the ventilated roof space is it needs to be ventilated, but we still want to have it wind tight. So we have here now an airflow that we want to get into the roof space. So you see in our eave, this opening, then here we have a 50 millimeter opening, and now the air can come in here. And now we have a ventilated roof space. Our weather tightness is given by our roof membrane that we see here, that blue line here, and our wall membrane that we continue across and bring it in here. And I normally say this should be, the distance here should be at least 1.5 meters. And by this, we are reducing the wind washing in that corner, because if you think about it, that green arrow that I shown here, this is where a lot of velocity can happen if the pressure difference between the inside of the roof and the outside of the roof is high. That happens, for example, when the sun is hitting the roof and we have far higher temperatures in the roof space and we have lower temperatures external, then that happens. Or it could be the opposite, that the outdoor temperature is still warm, and because of the radiation of the roof into the sky with minus 60 degrees, that the roof space already cooled down, but there's still warm air on the outside, that we have again a big pressure difference. And now there's a lot of air movement that needs to go through this 50 millimeters of a gap. If we would not have a membrane running around that corner, then we have a lot of wind washing there. In other words, what will happen? Our thermal insulation would be compromised like this. So this part of the thermal insulation will not perform any longer. And then because of the performance, we have the same situation then with the thing that I said we shouldn't do. We are having the chance of mold growth in that corner. In the extreme, probably still not happening if it's properly designed, but with this detail, you're able to avoid that performance drop and the risk of mold growth. And as well, you could theoretically have condensation in that thermal insulation in there. But if you put that membrane on there with a 1.5 meter into the roof space, so what I normally do, leave the membrane longer by 1.5 meters, cut it where your trusses are, and then just lap it in and then tape it a little bit. It doesn't need to be perfect. It's a wind washing. It's not an airtightness system. And that's the reason it will be okay if it's not 100% taped. We still need to think about economics, and that's normally okay. So that's now the detail that we're having here. You may have noticed that here we're having this little half circle in there with the dots in here. There was a product that I was using in Ireland, and it was a plastic product that was having a profile like this. And this was this 50 millimeters. And that was able to be folded. Here was that profile. Plastic at the bottom was just a plastic sheet, as well as a little bit of profile, so it's not too wobbly. And that was something that was able to be put on here to create that gap between the thermal insulation and the top. Works as well in retrofit situations, and that product is more or less shown in there. There are other solutions as well. You want to have something in there to make sure that this gap is actually created in there. You can do that as well with an L piece that is fixed underneath the rafter and then creates that gap. And you want to close it as well a little bit because of insects. Obviously, the insect closing can happen here already, but often that's not 100%. And then up here, we can close the fly mesh in there with a detail like this. Just a little detail going into perfection for a building and things that you can do. So this was now that detail for that getting a ventilated roof done with proper solutions for the wind washing and not having troubles. Now, another thing that I want to point out here is our gutter detail. So here, when we come to our gutter, you see now we have the roof membrane running down, and then we have here a metal flashing. Roof membrane is taped to that metal flashing, and then we're having the gutter here. Why are we doing this? Yeah, that's something that's often missed and not done. Again, here we're showing the ideal and the perfect solution is because the membranes, the roof membranes, they're not UV resistance. You normally, when you buy them, you see on there's written 90 days UV exposure or 180 days UV exposure or just 30, 60 days UV exposure. That's the time that the sun could hit that membrane, and the manufacturer is still giving you a guarantee that it actually works. This is something that's often overlooked, that they just run the membrane directly into the gutter. And what will happen? Our sun is here. The sun is now shining and is shining onto the membrane. And then the membrane is degrading over time. Sometimes it's a year, depending on the quality of the membrane. Sometimes it's 5 years, 10 years. But our house should stay there for 100 years. So definitely in that time frame, we will have a degradation of that membrane, and it will then fall apart. And what will happen when the membrane is not any longer there? Then we will have water coming in here. In this case, not a big problem because we have an overhang. However, you will then get watermarks in here and mold and dirt in that area as well here on first, probably on that flashing board, and then further in here. Doesn't look nice. It's normally not really having an impact on the performance. It's more an aesthetical thing then, but it could as well cause a rot in your rafter and your structure there and yada, yada, yada. This detail is taking care of that by putting that metal flashing in. And that's that metal flashing that we're showing here. We are running that underneath the membrane and run it directly into the gutter. And then we tape the membrane on top of it and try to tape it where the sun is not hitting any longer. And by that, we are taking care of that detail. So that was going into this detail and explaining you what you actually see on that picture. So we spoke about the airtightness, the ventilation, the thermal, the wind washing solution for a ventilated roof. All that is actually in here, and that's like our more or less ideal situation. So again, to the ventilation, we're having this ventilated space for our ductwork, and then here we have our service cavity where we can run cables and have our sockets in there so that the sockets are not penetrating our insulation. But let us move on now to retrofitting. Problem with retrofitting is that we can't put this piece in. This piece can't be put in to our roof structure without destroying the roof structure, without putting a new roof on. So how could we now solve that in the case we want to do a retrofit? So how does normally a retrofit look like? So we're having a timber frame, like this. And now we can get some thermal insulation in here. Yeah, and then we can get thermal insulation underneath here. And then if you do external solution, then you would have thermal insulation in here with putting the thermal insulation externally. Like there's a lot of details and things. Like I don't want to go into much details here. Just want to show you two solutions. So if this is a timber frame wall, then this works. Obviously, your air tightness now moves underneath this layer of thermal insulation. Otherwise, you're running into trouble with the dew point being already on the warm side of your air tightness system. If you're speaking about a cool tempered climate, if you're speaking about a hot climate where the air tightness is externally, then theoretically your air tightness would be up here. But let us not talk about it because most people live in a climate that is the air tightness could be on the inside, like Sydney, Perth, Melbourne, all these areas are still air tightness on the inside. Brisbane, Darwin is a different situation. In Europe, everywhere pretty much you would have the air tightness internally. You may have it in areas like Sevilla in Spain or some island states. You may need to do it outside, but again, don't make that by guesswork. If you're not 100% sure, use a WUFI analysis to find out where your air tightness system needs to go. But this is now the solution that we normally have. If this is a timber frame, if this is timber, easy peasy, no problem. However, if this is a masonry, now we're already having a problem because this is now a massive cold bridge because we're having now our heat going through our stone because it's a really good conductor. And now we're still having here the chances of mold growth. If you're working with a masonry, then you definitely need to put in here insulation on the wall internally, or maybe you get away with a little thermal insulation finish. If you're doing like a finish like this, like this traditional angle pieces, your stock work that is normally going into this area, and maybe do a thermal bridge analysis. This might be the solution for you to get it done. This is obviously, again, thermal insulation. That's like a foam. And with this, you have a detail for the corner that fits as well. Older buildings from a look as well in the UK. I've seen it a lot in Ireland. I've seen it a lot even in new builds. It's a way of avoiding a bad corner. So the reason they're doing it is plasterboard on plasterboard. They're not getting this corner done properly by putting that piece on. They're hiding that joint in the corner, and by that, it looks nice. So it's a way of getting away from that problem. If you're using here now a thermal insulation, by that, we are massively reducing the risk of mold growth. However, this is not the only solution. I want to go now for the people that are executing it. So more builders and execution people. The other thing, what you can actually do, that you actually move the roof. It sounds a bit crazy, but what you would do is you would put here a timber over your trusses, then use your props, moving up your whole roof structure and lifting the roof. Obviously, you have to take the roof ties off and things like this first. You can move the whole roof structure, and then you're able to move the roof so that you're getting enough thermal insulation on top of here. And move your roof line up. Your roof will then be up here. Obviously, your ridge line is changing, so you need to check again your building regulations. What is your R codes and things like that? Are you allowed to do it? Speak with your engineer regarding doing that. You need to be careful with it. We have done it that we lifted the whole house back in Germany, back in the day, that we lifted the whole house because we had to take beams out. But if you're doing a roof, it's normally really simple. You need to consider your point loads underneath your props, and then as well where you're lifting. You have to think about that. And then you need to recreate here with a timber or a thermal break if you're using masonry and you want to continue your masonry feel of it, or maybe there might be a fire regulation, so you can't use timber, then you could use a thermal break in there. But normally you just put then the timber in and land the whole roof on that timber and then fix the roof to the timber and the timber down to the structure underneath. Doesn't matter what the structure underneath is, if it's timber or masonry, it could be done in either case. That's what I wanted to show. That's something that people often don't think about. If you're doing retrofit and you do external insulation and you don't want to touch the inside, then with this option, you as well can now run your air tightness to the outside and run it here and then have your thermal insulation on here. This is now just really rough. If you want to know more about this, please let me know. I can do a little video on how to do retrofit in a brick structure or in a timber structure and how to do external and internal approaches. So if you want to get more content like this, please let us know. It seems like technical stuff is what people want these days. Happy to help, ask the questions. And that's the way that we normally try to explain bits and pieces with this visual and making things clear. So thank you, everybody that listened, and leave us a comment if you want more than this. Thank you. Bye-bye.